Okay, so this is the second example on 8.2. It says that the arc of the parabola y equals x squared from 1.1, from 1, 1 to 2, 4 is rotated about the y-axis. And we are trying to find the area of the resulting surface. So if we kind of sketch this, let's see, we've got the arc of the parabola from 1, 1 to 2, 4. So 1, 2, 3, 4, 1, 2, 3, 4. So from 1, 1, it looks like that's going to be about right there, to 2, 4. 2, 4 looks like that's going to be right there. We know it's a parabolic shape, so it's going to look something like that. And then we're going to rotate that around the y-axis. So if I kind of go to the other side, just to draw what it would look like on the other side, looks something like that. So ultimately, it's going to have something of a shape that looks something like that. We're trying to basically find the outside of the surface of this thing. Again, not the volume, the surface. So this is, let's just go ahead and label that. That's the point 1, 1, and that's the point 2, 4. All right, so if we remember, the surface area is going to be an integral of 2 pi r times L dx. So we need to define our R and our L. This thing is going to be, again, it's revolved around the y-axis, so our radius here is just going to be x. So we're going to integrate 2 pi x, because it's an x distance. And the L part, remember the arc length, is the square root of 1 plus, now I need the derivative of our function squared. So we're going to go back up here, and y prime is 2x, y prime squared then would be 4x squared. So underneath of the square root, I'm going to get 4x squared dx. So in order to do this problem, oh, and by the way, x is going to change from 1 to 2. 1 to 2. So to do this problem, I have 1 plus 4x squared underneath of the square root, and I have the extra x on the outside, so it looks like we're probably going to have to do a u substitution in order to actually calculate the integral. So off to the side here, u is going to be 1 plus 4x squared, which makes du 8x dx, solving that equation right there for dx. Dx will be du over 8x. So we're going to go ahead and substitute that stuff back into our integral. Now I am going to change the bounds. If I plug a 1 in for x in my u equation, I get 1 plus 4 times 1, so that's 5. If I plug 2 in to this equation right here, I'm going to get, 2 squared is 4, times 4 is 16, plus 1 more is 17. So my upper bound becomes 17. The 2 pi can come out to the front. It's a constant. X is still x. What's under my square root is now u, because that's what that was. And my dx is now du over 8x. The nice thing is algebraically, those x's are going to cancel out. That 8, which is in the denominator, comes out to the front as 1/8. So 2 pi over 1/8 will simplify to pi over 4. Integral from 5 to 17 of the square root of u, but the square root of u can be written as u to the 1/2. So now I'm ready to go ahead and take antiderivatives. So I'll get pi fourths. Antiderivative of u to the 1/2 is u to the 3/2 times 2/3. And we'll evaluate that from 5 to 17. So simplifying the pi fourths times 2/3 is going to end up with pi sixth. And then plugging in the 17 is going to give me 17 to the 3/2. Plugging in the 5 will give me 5 to the 3/2. And to be completely honest with you, there's really not much of a reason to simplify that any further. You could write the 3/2 as 17 root 17 and then 5 root 5, but really there's no reason you would have to do that. This right here is perfectly acceptable. So that problem is actually not too long. Hopefully that was okay for you guys, and that should be enough to complete the homework.